damn it, I've run out of space just as I was about to get the crucial bit. I'll keep you going. Right, so that's saying 3.78. Okay, and what I'm about to do, if I can put the, get it into the right spot so when I press it. So what I'll do is, if I press 1 on here, then that should actuate the relay, and you'll hear it click. There. Right, and then, oh, it's actually gone up. Right, so it's gone to high. That's interesting. Alright, so what I'm looking for is that cell, this value here, to start going up. So if I now turn it on, and then we might see, oh, there you go. You see how it's on about 3.8 now. Let's turn it off again. And now it's gone to 3.78. Yeah? 3.8, 3.78. And we should see a corresponding drop here. Let me put the light back on. So I'll turn it on. There you go. 4447. And now turn it off. Goes up to 4468. So obviously the transferring power. Now obviously you've got resistance in the wires, so that's causing that. Let's put it onto the cell itself. I just want to see it on the meter. So I think if I put it onto the negative side, doesn't matter if it shows a negative voltage, because we know it's the same. Right, so that's saying 3787, right? 37803. Well, that's near enough, right? And then I'll turn it on. There you go. You can see the voltage has risen, obviously, slightly. Yeah, so it's obviously charging it. We've got a voltage drop in the wiring, but it's charging it. Yeah. Right. So what I'm going to do is I'm actually going to set it up in the software. Right. I just want to check to see if it actually will shut it off. Now, the average voltage, obviously this cell we did see when we were metering, that's 4 volts. This one's about 3. Let's just say these two are both 3.8, right? Which means the average voltage is going to be somewhere around about 3. Just under 3.9. Just off the top of my head, it's like 3.87 or something, right? So what I'm going to do is, I'll actually put the power pack on as well, and then we'll put that, and we'll set that one to actually turn off the charge when it gets to 3.9, which it probably will reach, and then we'll see it do that. Well, we won't see it now, because it'll take a while. But what I want to do is just basically in the software, so I'm going to adapt the software so that it actually puts a limit on that, and then when it sees it do that, it basically shuts off the power. You know? And then we'll see it. Because that's essentially the BMS cell balancing function, but just on one cell. And then ultimately, we need to do it on the other cells. We need to obviously make these values more accurate, and I've got an idea for getting the Arduino itself to kind of self-check the accuracy using an LM317, but I haven't developed that yet. And then the reason why it's better to do that is because then that means it can calibrate itself, you see, so you don't need to deal with anything calibration wise, but it could end up getting quite complicated, so I don't know, we'll see. Anyway, so that's where we're currently at right now. As you can see, it'll work, and what I'll do is I'll just do a follow-up video once I've done it so we can actually see it and see what it does.